Have you ever wondered how TikTok knows exactly what video will make you scroll for 3 more hours at 2 a.m.? Or how it can predict with terrifying accuracy that you'll love a dance video from someone you've never heard of in a style you didn't even know existed? What if I told you that the algorithm feeding your addiction isn't just using traditional computer science, it's actually employing principles from quantum mechanics, the most mysterious and counterintuitive branch of physics ever discovered? Today, I'm going to reveal how your smartphone has become a quantum prediction machine using the same mathematical principles that govern subatomic particles to control your dopamine responses. The connection between quantum superposition and your For You page is more real than you think, and the implications will change how you see every swipe, every like, every algorithmic recommendation for the rest of your life. The story begins in the seemingly impossible world of quantum mechanics, where particles can exist in multiple states simultaneously until they're observed. This concept, called superposition, sounds like science fiction, but it's the foundation of how quantum computers process information. Instead of classical bits that are either 0 or 1, quantum systems use quantum bits, qubits, that can be 0, 1, or both at the same time. This allows quantum systems to explore multiple possibilities simultaneously, making certain types of calculations exponentially faster than traditional computers. And here's the mind-bending part. Modern AI algorithms, including the one that controls your TikTok feed, are designed to mimic this quantum behavior using classical computers. Emmy Noether's insights about symmetry and conservation laws help us understand why quantum-inspired algorithms are so effective at pattern recognition. In quantum mechanics, particles maintain certain symmetries that allow them to exist in superposed states. Similarly, TikTok's algorithm maintains mathematical symmetries that allow it to consider multiple potential preferences simultaneously. When you open TikTok, the algorithm doesn't just look at your previous behavior and make simple predictions. Instead, it creates a quantum-like superposition of all possible videos you might have, weighted by probability, and then collapses this superposition into specific video recommendations based on your interactions. Think about how TikTok's recommendation system actually works at a fundamental level. Traditional recommendation systems might analyze your past behavior and suggest similar content. If you watched cat videos, you get more cat videos. But TikTok's algorithm is far more sophisticated. It creates what computer scientists call a high-dimensional probability space, where every possible video exists in a state of potential relevance to you. This is mathematically analogous to quantum superposition, where every possible outcome exists simultaneously until measurement forces the system to choose a specific state. The quantum-like nature becomes even more apparent when we examine how TikTok handles uncertainty and probability. In quantum mechanics, particles don't have definite properties until they're measured. They exist in probabilistic states described by wave functions. TikTok's algorithm creates similar probabilistic models of your preferences. It doesn't assume you definitely like or dislike certain types of content. Instead, it maintains probability distributions across thousands of different preference dimensions: humor style, music taste, visual aesthetics, topic interests, time of day preferences, and countless other factors. When you interact with a video by watching it to completion, liking it, sharing it, or scribbling past quickly, you're essentially performing a quantum measurement on this probabilistic system. Your action collapses the superposition of possibilities into a more definite state, updating the algorithm's understanding of your preferences. But just like in quantum mechanics, this measurement doesn't reveal absolute truth about your preferences. It just shifts the probability distributions, preparing the system for the next round of quantum-like predictions. The mathematical frameworks underlying these processes are surprisingly similar to those used in quantum field theory. Both systems deal with complex probability amplitudes, interference effects, and the challenge of extracting meaningful information from probabilistic systems. Machine learning researchers have explicitly borrowed mathematical tools from quantum mechanics to create more powerful algorithms. Techniques like quantum annealing, variational quantum algorithms, and quantum neural networks are being adapted to run on classical computers, creating hybrid systems that capture some of the power of quantum computation without requiring actual quantum hardware. TikTok's algorithm also exhibits something analogous to quantum entanglement, the phenomenon where particles become correlated in ways that seem to violate classical physics. In the TikTok ecosystem, users become entangled through their viewing patterns. When one user discovers and engages with a particular type of content, this information instantly affects the probability distributions for millions of other users who share similar preference patterns. The algorithm creates correlations between users that are so complex and multidimensional that they resemble the mysterious correlations found in entangled quantum systems. This quantum-inspired approach explains TikTok's almost supernatural ability to surface content that you didn't know you wanted. Traditional algorithms might miss these connections because they think in terms of definite categories and linear relationships. But quantum-inspired systems can explore the probabilistic space of all possible connections simultaneously, finding patterns that exist in superposition, relationships that are neither definitively present nor definitively absent, but exist in a quantum-like state of potential correlation. The algorithm's treatment of novelty and exploration also mirror quantum behavior. In quantum mechanics, particles can tunnel through energy barriers that should be impossible to cross according to classical physics. TikTok's algorithm performs similar kind of probabilistic tunneling when it occasionally shows you content that seems completely unrelated to your established preferences. These apparently random recommendations aren't actually random. They're calculated leaps across the probability landscape, designed to discover new regions of content space that might resonate with hidden aspects of your personality. The speed and efficiency of these quantum-inspired calculations is what makes TikTok's real-time personalization possible. Every time you open an app, the algorithm performs billions of probabilistic calculations, considering vast numbers of potential video user matches simultaneously. This parallel processing approach, inspired by quantum superposition, allows the system to evaluate possibilities at a scale that would be impossible with purely sequential classical computing approaches. But the quantum analogy goes even deeper when we consider how TikTok handles information and uncertainty. In quantum information theory, the act of measurement inevitably disturbs the system being measured. Similarly, TikTok's algorithm recognizes that the act of showing you content changes your preferences. Each video you watch slightly alters your taste profile, creating a feedback loop between observation and the system being observed. The algorithm must constantly account for this measurement problem, predicting not just what you like now, but how your preferences will evolve in response to the content it shows you. The mathematical concept of quantum interference also appears in TikTok's algorithm. In quantum mechanics, probability amplitudes can interfere constructively or destructively, creating patterns that seem to violate classical probability theory. TikTok's recommendation system exhibits similar interference effects when different preference signals interact. Sometimes multiple weak preference indicators can combine constructively to create a strong recommendation. Other times, conflicting signals interfere destructively, causing content that should theoretically appeal to you to be filtered out. The algorithm's ability to handle context and ambiguity also reflects quantum-inspired thinking. In classical logic, statements are either true or false, but in quantum logic, propositions can exist in superposed states of truth and falsehood. TikTok's algorithm handles the ambiguity of human preferences using similar mathematical frameworks. It doesn't try to determine whether you definitively like or dislike certain types of content. Instead, it maintains probability distributions that capture the full spectrum of your potential reactions, including contradictory preferences that might exist simultaneously. The temporal dynamics of TikTok's algorithm also exhibit quantum-like properties. Just as quantum particles can be entangled across time as well as space, TikTok's system creates temporal correlations in your content experience. Videos you watch now influence not just immediate future recommendations, but create probability ripples that affect content suggestions hours or days later. The algorithm maintains a kind of temporal superposition where past, present, and future preferences exist in quantum-like correlation. Even the social aspects of TikTok's algorithm reflect quantum mechanical principles. In quantum field theory, particles are described as excitations in underlying fields that permeate all of space. Similarly, TikTok treats cultural trends and viral content as excitations in an underlying field of collective human attention. When content goes viral, it creates ripples in this attention field that propagate to users who haven't even seen the original content yet, influencing their probability distributions through quantum-like field effects. The algorithm's approach to creativity and emergence also mirrors quantum phenomena. In quantum mechanics, complex systems can exhibit emergent properties that aren't predictable from their individual components. TikTok's algorithm facilitates similar emergence by allowing unexpected combinations of content, users, and trends to interact in its probabilistic space. New forms of entertainment and cultural expression emerge from these quantum-like interactions, creating content categories that didn't exist before and wouldn't have been predictable from traditional algorithmic approaches. The personalization technology extends beyond just content recommendation to include timing, presentation, and even the psychological framing of content. The algorithm uses quantum-inspired techniques to optimize not just what you see, but when you see it, how it's presented, and what emotional state you're likely to be in when you encounter it. This creates an experience that feels almost telepathic in its ability to deliver the right content at exactly the right moment. But perhaps the most profound quantum-like aspect of TikTok's algorithm is its relationship with consciousness and observation. In quantum mechanics, the role of consciousness in measurement remains one of the most mysterious and debated aspects of the theory. Similarly, TikTok's algorithm creates a feedback loop between digital consciousness, the AI system, and human consciousness, the user, that transforms both participants in the interaction. Your attention and engagement literally shape the algorithm's understanding of reality, while the algorithm's recommendations shape your attention and preferences in return. The implications of this quantum-inspired approach extend far beyond entertainment. The same mathematical frameworks being used to personalize your TikTok feed are being applied to medical diagnoses, financial markets, climate modeling, and artificial intelligence research. We're witnessing a new kind of computation that borrows the probabilistic, parallel, and non-classical aspects of quantum mechanics to solve problems that classical computers struggle with. As quantum computing technology continues to advance, the line between quantum-inspired algorithms and actual quantum computation will blur. Future versions of TikTok and similar platforms might run on hybrid quantum classical systems, taking advantage of genuine quantum superposition and entanglement to create even more sophisticated personalization technologies. The quantum nature of these algorithms will become less metaphorical and more literal. The next time you find yourself lost in an endless scroll through TikTok, remember that you're not just consuming content, you're participating in a quantum-like information system that exists in a superposition of all possible entertainment experiences. Every swipe is a measurement that collapses probability waves into reality. Every video is selected from a quantum field of potential content that exists in probabilistic suspension until your attention brings it into being. You're not just using an app, you're interfacing with a digital quantum system that's learning to predict and shape human consciousness itself. The algorithm isn't just showing you what you want to see, it's using the fundamental principles of quantum reality to explore the infinite possibility space of what you might want to see, and then materializing those possibilities into the addictive stream of content that keeps you scrolling until the early hours of the morning.